silent sacred catacombs, freedom meets with destiny. If I choose to dance the flame, bear the breath of life in me. I would love to bear my name, in others' words my mark you'll see. Quiet place down deep in my bones, deep in the bones of me. In silent sacred catacombs, freedom meets with destiny. If I choose the warrior's way, I'll protect this place from harm. Though I might die most any day, my children all will carry on. I might lead a humbler path, just a fragment I confess, finding wounds from battles where heal others from my brokenness. It matters not which path I choose, none may claim the nobler part, but to myself I must be true. One will beckon to my heart.
Because the human body is filled with nutrients, many microorganisms would like to take up residence in it. These organisms would have killed off the human race long ago were it not for our built-in army of defense known as the immune system.
I hear the wound his foot again. Got Joe down the street.
Well, it won't get this fellow. I open up flashes and packed into granules, and I could chew up 10 or so by myself. Look at you. You couldn't be stickier or ready to eat up some foreign protein.
That's the part of the plan I don't quite understand. I mean, what if I end up eating my fellow cells in the process of destroying the enemy?
That's where we come in.
Who said that? I don't see one.
We're down here. We're small because we're a protein, not a cell like you. But we tell you which cells to attack and which ones to leave alone.
But how do you know?
I know, because I'm just always attracted to those bad guys. It's some fatal attraction. They seem so wild, so exotic, so different from everyone else I see all the time. I just can't keep myself from getting attached to them. So if you see me with someone, you know they've got to be bad.
But what will happen to you if I attack them?
We'll get torn up to bits along with the guy you're after.
Gosh, I'd hate to do that to you.
I know. I wish I could keep myself from getting into these self-destructive relationships. But everyone in my family does the same thing. I don't know how to break the cycle, so I'll just do what I know. At least I know it does this fellow so good.
Well, we'd better go on patrol if we're going to keep this body from catching that pneumonia.
Wait, I'm not quite sure I know what to do yet.
Don't worry, you'll just do it. Our genes have been telling us how to do this for generations. You can't go wrong.
Yeah, cool.
Look.
So this looks like a pretty nice place to hang out. Good food, nice climate, a good landscape.
What about these guys? They're kind of dangerous.
They seem pretty stupid. I don't think they know that we're here.
Mediation, the best remediation.
panic. It could just be an innocent bit of pollen. Under your breathing exercise.
I'm sorry, I just get so anxious. There's been a breach. I can feel it. Look right there. That's not a pollen. It's a bacterium.
Where? That means there could be more.
We could be surrounded soon. This is it. We have to degranulate. Release histamine.
Damage! Damage here!
Hi, nice coat. Where'd you get it?
Thanks, it's phenomenal. It's the baddest brand in town.
Hey. I get tired of seeing the same old boring protein coat all the time.
Hey there, you're looking good. We seem to be headed the same way. I'm on my way to the lungs. They're just around the bend where all the branches are.
Fine. Well, yes, I'm looking for a cozy new home. I was raised in the lungs of the kid next door. Got evicted when he coughed.
Nice protein coat. It must be in style this year. I think I saw one on someone else I just passed.
Another important member of the team is the neutrophil. He is one of the first to attack the invaders. He digests the remains of the battle, trapping them in pus and removing them from the body. The neutrophil is destroyed in the process.
I have the perfect disguise. Those compliment babes, they go for protein. I have my protein hidden under the sugar coat.
No, don't blow your cover. They're not really worth the cost.
Aha, I see who you are.
Just my type. You know, when I first saw you, I didn't notice you. But now I know that you really are my type.
No, get rid of her. You know who she is. No, God.
Gotta clean up this mess again. I'm coming, Elizabeth.
Oh, it looks like there was a bloody battle here. It's a good thing we just happened by.
Don't worry, now that I'm here, you'll have a clot to stop all that bleeding in just a few minutes.
Here, we'll make a bridge over this wound so that it will heal.
In addition to dealing with invaders from the outside, certain immune cells, known as natural killer cells, also destroy our own cells when they become cancerous. We all have cells that become cancerous, but most of us don't get cancer because these natural killer cells protect us.
Joe, oh my gosh, Amanda! Is that you? It's been a long time. Remember when we and that crazy Josie were busy building up this liver?
Oh, yes, those were the days. We had such energy and such mission. But now we're about ready for apoptosis. Whew, my genes are telling me it's time.
Me too. I wonder whatever happened to that crazy Josie. We should all be heading out together.
I'm Josie.
What? No, you're not. You can't be.
Josie's supposed to be old like us.
Oh, but I am Josie. I figured out the secret to eternal life. I found this nasty thing inside of me, ticking away my time, set to end me when the bell rang. But I was too smart for it. I took it apart so it couldn't do me in.
You disabled your apoptosis gene?
And now you get to live forever?
No, but I can grow faster than regular cells, and pretty soon all cells will be just like me. I can even multiply myself.
I'm gonna live forever, fly through the sky like a flame. I'm gonna live forever, baby, remember my name.
Josie, you've become a cancer cell. Aren't you afraid the natural killer cell will come and get you?
That little cell hurt me? You've gotta be kidding.
Well, how about that? She didn't last as long as we did.
Imagine just that little cell. Who would have thought?
Unfortunately for the human race, bacteria and viruses are able to change themselves very rapidly. From their standpoint, such change is necessary for their survival. This has, in turn, forced the human race to evolve a more complicated system for recognizing that an invader is in the body.
What's a homeless microbe supposed to do? Homeless microbe, homeless hungry microbe. Got to find a way to get through these guys' defenses. But every time I find a place, there's a macrophage staring in my face. What's a homeless microbe supposed to do? Homeless microbe, homeless hungry microbe. They know us 'cause we don't have the MMC. Homeless microbe, homeless hungry microbe. If we steal their genes, we can make a fake ID. And if that plan don't work out well, we can hide ourselves inside of their cells. Then we'll have a hope for families. Happy microbe, happy, happy microbe.
Because there are millions more microorganisms than there are genes, if we relied completely on our inherited innate immunity, we could be easily destroyed by new microorganisms which our genetic ancestors had never seen. In order to deal with this challenge, the straightforward complement signal is replaced by an elaborate intelligence network featuring T cells, which produce highly variable recognition molecules, and B cells, which turn these molecules into antibodies. This can identify even invaders which are hiding inside the cell.
The immunity of adaptation, a never-ending struggle of recreation. How do you use just 100 genes to fight a million bad guys you have never seen? An antibody is a permutation of several different pieces, 100 variations. We make millions, there is little doubt. Some will grab the bad guys and the white cells take him out. Adaptive immunity uses major histocompatibility. Antigens and MHC tell T cells who's the enemy. There's a reason for the inflammation. Brings the white cells to the right location. And that fever more antibodies makes. Your body is a war zone, it's no wonder that you ache. Adaptive immunity uses major histocompatibility. Antigens and MHC tell T cells who's the enemy.
In order that these more advanced members of the immune system not destroy our own bodies, they must be educated so as to distinguish the body's substances from those created by an intruder. Those which cannot do this must destroy themselves in a process called apoptosis. T-cell education occurs in the thymus. B cells are educated in the bones. Let's listen in as recruits are taking their final exam.
You both understand that upon graduation, those of you who survive this final exam will be released into the lymphatic system to circulate throughout the body. Through your education, hopefully, you have come to know who you are as part of this body. I remind you of the pain and suffering and even death which you will inflict upon this body if you do not know who you are. It is therefore necessary that those of you who have not fully penetrated the nature of your identity must die.
See, I told you, if we don't graduate, it's apoptosis for us.
You will each produce protein you will use to identify an invader and show it to the guardian of the bridge.
What is your name? I am T cell 5,281,312.
What is your quest?
I will defend this body that has raised me.
Show me your protein.
I am sorry, your protein would bind the pancreas. If you were to multiply yourself within this body, it would suffer from juvenile diabetes. You cannot graduate.
That's so unfair. I mean, she studied hard. She learned the MHC handshake. And just like that, wham, she's gone. Just because she had the wrong proteins. It's not fair.
But just think what would have happened if you had graduated to the lymph nodes and traveled to the pancreas. You remember the pancreas, don't you?
What is your name?
I'm T cell 8,721,964.
And what is your quest?
I will defend this body that has raised me.
Show me your protein. Good, good. So tell me, what is the wind velocity of a full-landed swallow?
An African swallow or a European swallow?
Excellent! You will graduate and travel to the lymph nodes.
Cells such as the killer T cells, the helper T cells, and the B cells, and a special molecule known as the major histocompatibility complex, MHC for short, allow us to fight off viruses which try to hide inside of our cells. MHC inside of antigen-presenting cells carries pieces of whatever is inside the cell to the outside, where T cells can see it. In order that normal things like nutrients or pollen not trigger an immune response, T cells that bind to something that is not normally found in the cell are put to sleep. Cells such as the killer T cells, the helper T cells, the B cells, and a special molecule known as major histocompatibility complex, MHC for short, allow us to fight off viruses which try to hide inside our cells. MHC inside of antigen-presenting cells carries pieces of whatever is inside the cell to the outside where T cells can see it. In order to activate only the best T cells for the job, other T cells are put to sleep. This is accomplished by a process known as co-stimulation, where basically the T cell and the presenting cell have a chemical conversation.
Here you go, MHC. I've chewed up this protein pretty well.
Hey MHC, nice to see you looking like yourself today.
Hey, MHC. You seem to have something very interesting with you.
have to stick around here a while. Do you all have this inside?
No B7 here. All is normal. We're feeling sleepy. We're letting go and entering a state of energy.
Oh, I'm feeling rather energetic. I think I'll take a nap.
If a virus has made its home inside this cell, the ending will be very different. A molecule called B7 will indicate that all is not normal inside, and the T cell, recognizing a product of the virus, will initiate a response that will destroy infected cells and viruses.
If I hide in here, those compliment babes will never see me. Cool, I can use this ribosome to make more of me in just a couple of weeks. I can be mayor of a whole cell full of folks just like me. I'll just insert my DNA right about here. Hey, stop that. I need those.
Whoa, this is suspicious. My T-cell receptor is sticking. If you've been invaded by an enemy, send me your B7.
B7 here. Yes, I've been invaded. Activate and clone yourself. Alert the B cells. Tell them to differentiate and make this antibody.
Helper clone, go to the lymph nodes and instruct the B cells.
Quick, become a plasma cell. We need antibodies that know this code. Here's the gene for my receptor. It will let you make antibodies that will bind to the virus and infected cells.
We had better slow this process down before we inadvertently kill our host by causing sicknesses.
We sure took care of that. My protein stuck to the invader really well. It showed my B-cell partner how to make strong antibodies that alerted the macrophages and neutrophils. I had better report the lymphatic library so that there will be a record of that good antibody for next time his relatives try to move in.